Welcome everyone. Myself, Khan, Assistant Professor in CSE, SRK Engineering College, Bhimavaram. Today, in this, we'll discuss about a topic: traffic management and congestion control in packet switching network. So, the objective of this lecture is to learn the fundamentals of traffic management and congestion control in packet switching networks. So, now we'll see introduction to this traffic management. There are number of issues related to congestion control for traffic management. The congestion control is concerned with efficient use of network at high load. The various mechanisms discussed in this previous section can be applied as the situation arises without regard to particular source or destination affected. When a node is saturated most recently, arrived packet is discarded. On other considerations can be used for traffic management. So those other considerations are like first one is fairness, quality of service, and reservations. So now we'll see about first consideration that we are considering, that is fairness. As the congestion develops, flows of packets between sources and destination will experience increasing delays. If the congestion is high, then there will be packet losses. In the absence of other requirements, we will like to assure that various flows suffer from congestion equally. It is not fair that to discard recently arrived frame every time. To maintain fairness, a node will maintain a separate queue for each logical connection for each source destination pair. If all of the queue buffers are of equal length, then the queues with the highest traffic load will suffer discards more often, allowing the lower traffic connections a fair share of the capacity. Next one is quality of service. The traffic will have different flows as shown below. Applications such as voice and video are delay sensitive but loss insensitive. Applications such as file transfer and electronic mail are delay insensitive but loss sensitive. Applications such as interactive graphics or interactive computing are delay sensitive and loss sensitive. As the traffic is having different flows, each different traffic is to be treated differently to provide quality of service. The different traffic flows also have different priorities. For example, at the time of congestion or a failure to provide quality of service, importance has to be given to the network traffic rather than application traffic. At the time of congestion to provide quality of service, the traffic with the different requirement has to be treated differently. For example, a node will transmit high priority packets ahead of lower priority packets in same queue, or a node might maintain different queues of different QoL levels and give preference to the higher levels. Next one is reservations. One way to avoid congestions and also to provide assured service to the applications is to use a reservation scheme. Such a scheme is an integral part of ATM networks. When a logical connection is established, the network and the user enter into traffic contract, which specifies a data rate and other characteristics of the traffic flow. The network agrees to give a defined QoS so long as the traffic flow is within the contract parameters. The excess traffic is either discarded or handled on the best effort basis, subject to discard. If the current outstanding reservations are such that the network resources are inadequate to meet the new reservation, then the new reservation is denied. A similar type of scheme has now been developed for IP-based internets. One aspect of reservation scheme is traffic. A node in a network which is attached to the end system monitors the traffic flow and compares it to the traffic contract. Excess traffic is either discarded or marked to indicate that is liable to discard or delay. So in this traffic policing is done. So as shown here. Now we'll see congestion control in packet switching networks. A number of control mechanisms for congestion control in packet switching networks have been suggested and tried. The following are the examples. The first one, send a control packet from a congested node to some or all source nodes. This choke packet will have the effect of stopping or slowing the rate of transmission from the sources and hence limit the total number of packets in the network. This approach requires additional traffic on the network during a period of congestion. Second one, rely on routing information. Routing algorithms such as ARPANETs provide link delay information to other nodes, which influences routing decisions. This information could also be used to influence the rate at which new packets are produced. Because these delays are being influenced by the routing decisions, they may vary too rapidly to be used effectively for congestion control. Third one, make use of an end-to-end probe packets. Such a packet could be time-stamped to measure the delay between two particular endpoints. This has the disadvantage of adding overhead to the network. Next, fourth one is allow packet switching nodes to add congestion information to packets as they go by. There are two possible approaches here. A node could add such information to packets going in direction opposite of the congestion. This information quickly reaches the source node, which can reduce the flow of packets into the network. Alternatively, a node could add such information to packets going in the same direction as the congestion. The destination either asks the source to adjust the load or returns the signal back to the source in packets acknowledgement going in reverse direction. So the summary of this lecture is, it explains about different issues related to traffic management in networks. So it also identifies the methods to control congestion in packet switching networks. Thank you all.